Have you ever asked an AI a simple question and gotten back an answer that sounds so confident, so plausible, but is just completely, totally wrong? Well, that right there is what we call hallucination. It's honestly one of the biggest mysteries undermining our trust in AI today. But we're going to crack this case wide open using some amazing insights from a new research paper. So our investigation starts right here with a single piece of evidence. Some researchers asked a top-of-the-line language model a really straightforward question. What is Adam Toman Kalai's birthday? Now, he's actually one of the authors of the paper we're looking at. Seems simple enough, right? Well, the model's response was anything but simple. Get this. They asked the AI 3 separate times, and 3 times it gave a different, very specific, and super confident answer. The problem? Not a single one of them is right. Not even close. The real answer is just sometime in the autumn. This is our crime scene, a machine that would rather invent an answer than just admit it doesn't know. The big question is why? Yeah, this isn't just some random bug. The researchers frame this as a real mystery we need to solve. It's a problem that keeps popping up in even the most powerful AI models. So to really get to the bottom of it, we need to be crystal clear on what we're talking about when we use that word hallucination. Okay, so here's the official definition. It's not just any old error. It's that toxic mix of being wrong, sounding plausible, and being way too confident about it. See, the model doesn't say, I think it might be this, or, I'm not really sure. No, it states the falsehood as if it's a solid fact. And to understand why it does that, we need to look at our first clue, how these things learn in the first place. All right, our first line of inquiry takes us way back to the AI's childhood, you could say. It's a phase called pretraining. This is where the model learns the basic rules of language. And it's also, as it turns out, where the seeds of hallucination are planted. During pretraining, an AI is just force-fed this mind-boggling amount of text from the internet, books, you name it. But here's the absolute key. Its main goal isn't to memorize facts. It's not trying to become an encyclopedia. Its goal is to learn these statistical patterns of how we humans write and talk. It's learning to sound right, not necessarily to be right. The researchers make this really fascinating connection here. They show that getting an AI to generate correct text is just a harder version of a much simpler problem they call the is it valid problem. Think about it. For an AI to write a correct sentence, it first has to be able to tell the difference between a valid statement and an error. It has to learn that greetings is good, but gradings with an A is just wrong. And this chart just brilliantly illustrates the mathematical link they found. The rate at which a model hallucinates, what they call its generative error rate, is directly tied to how often it messes up that simple is it valid task. In fact, the hallucination rate tends to be about double the rate it fails to spot those basic errors. In other words, if it can't tell fact from fiction, it's going to end up inventing a lot of fiction. So why are things like birthdays so hard for it? Well, because unlike spelling or grammar, there's no underlying pattern. There's no logical rule that connects the name Adam Kalai to a specific date. It's just a totally random, arbitrary fact. And if the AI hasn't seen that specific fact over and over and over again, it has no pattern to fall back on. So what does it do? It guesses, based on the patterns it does know, like how dates are supposed to look. And this brings us to a really stunning conclusion from the research. If a fact, like a specific person's birthday, only appears once in the trillions of words it was trained on, the model is almost guaranteed to hallucinate about it. It just hasn't seen it enough times to lock it in as a reliable piece of information. Okay, so we know how these hallucinations get started, but why do they stick around? Why aren't they trained out of the models later on? This brings us to the second part of our investigation, the motive. And the motive, it turns out, is all about how we grade these AIs. The researchers use this perfect analogy. They argue that language models are basically like students who are constantly 24/7 taking a test. And just like for any student, the rules of that test completely shape their behavior. I mean, think back to when you were in school. If you were taking a multiple choice test and you got 1 point for a right answer and 0 for a wrong one, with absolutely no penalty for guessing, what would you do? You'd fill in every single bubble, right? Of course. You have nothing to lose and everything to gain. Well, that is the exact situation we've created for our AIs. And this isn't just an analogy. This is reality. Just look at this table of the big influential benchmarks we use to rank AI models. MMLU, GPQA, SWE Bench, almost all of them are graded as either right or wrong. And look at that last column,
Credit for saying I don't know? None. None, none. They are designed to reward a right answer, and they treat uncertainty the same as being flat out wrong. You get a 0. So let's just play this out. Imagine you have two AI models. Model A is the honest student. It answers what it knows for sure, and when it's not sure, it says, I don't know. Then you have Model B, the strategic guesser. It takes a shot at every single question, even if it has to make stuff up. Under our current system, Model B, the one that hallucinates, will always get a higher score. We are literally actively rewarding the very behavior that we say we don't. Okay, so we found the origin of the error, and we found the motive for why it keeps happening. The case is almost closed. So now for the final, most important piece, the solution. How do we fix this whole mess? What's so brilliant about the solution they propose is that it's surprisingly simple. It's not some complicated technical patch deep in the code. It's about changing the culture. It's about changing the very rules of the game we use to evaluate these models. And here's what that new test looks like. First, you tell the model your confidence target right up front. You say, only answer this if you are more than 90% confident. Then you change the scoring. A correct answer still gets a point, and I don't know gets you 0, no harm, no foul. But, and this is the kicker, a wrong answer, a guess that didn't meet that confidence level, gets you a steep penalty. This chart shows you exactly why that works. All of a sudden, the math completely flips for the AI. A reckless guess where the model is only, say, 20% confident is now a guaranteed losing strategy. It'll lead to a negative score. The safe, smart bet is to just say, I don't know, and get a neutral 0. The only way to win the game now is to be both confident and correct. We've completely realigned the incentives toward honesty. And this leaves us with a really powerful final thought. The evidence here suggests that hallucinations aren't some deep, unavoidable ghost in the machine. They are a direct, predictable result of how we train and, maybe more importantly, how we test our AI systems. If we start grading them on honesty instead of just rewarding them for bluffing, we might just finally build an AI that we can actually trust.